Hi there, in the last video I explained the vector or the cross product, okay, of two vectors, and I showed you a way in order to work out the vector product straight away using the determinant of a 3x3 matrix. Okay, so if you haven't watched the previous video, I would encourage you to do that before continue on with this video. So let me now go through some examples of how this procedure is applied. So let's take a brand new page. So example number 1. Let's underline that. So the question is, given that vector v1, so that is given by 2i plus 3j minus 2k, and we have a vector v2, okay, so that is given by 3i minus 5j plus 7k, and we need to work out, so the question is to calculate v1 cross v2. Okay, so let's work out the cross product of v1 and v2. So if we go back, so remember in the previous video, in order to work out the cross product, okay, I usually use the determinant of a 3x3 matrix. So this is by far for me the easiest method in order to work out the cross product of two vectors. So let me use this approach, and let me also show you how this approach is applied with this example. So v1 cross v2. So remember in the last video, so I hope you can see that. So in the last video, this is the determinant of a 3x3 matrix, so I'm going to be using this method. The first row, you write down the unit vectors I, j and k. So you write down I, j and k, the elements along the first row always, so it's always in the order I, j and k. In the second row, you write down the coefficients of I, j and k in v1, so whatever you start with here, okay? So the coefficients of I, j and k in v1 are 2, 3, minus 2. So 2, 3, minus 2. And then along the third row, you write down the coefficients of I, j and k in v2. So the coefficients are 3, minus 5 and 7. So 3, minus 5 and 7. So once you've done that, in the last video I explained that there's signs associated with each of these rows of a 3x3 matrix. So when we expand, so I normally expand using the first row, but you could also expand using columns also, but I'm going to expand using the first row. The signs associated with the first row are plus, minus and plus. Okay, so what I normally do is I write down plus, minus and plus. These are the signs associated with the first row. And then I expand using the first row of this matrix. So it's plus I multiplied by the determinant of a 2x2 matrix. And remember, to get the elements of that 2x2 matrix, just cross out the row and the column. So the row and the column containing I. Okay, so if I cross out the row and the column containing I, I'm left with 3, minus 2, minus 5, 7, okay, minus j, so minus j, multiplied by, cross out the row and the column containing j, we have 2, minus 2, 3, 7, so 2, minus 2, 3, 7, so these are the elements for the second determinant, plus k, so plus k, multiplied by, cross out the row and the column containing k, we're left with 2, 3, 3 minus 5. So 2, 3, 3 minus 5. Okay, so let's continue further. So remember, when expanding a 2 by 2 determinant, so remember in the last video I used the colours red and green. So first multiply the elements along the red, what we call leading diagonal, and then subtract, then multiply the elements along the green diagonal, known as the lateral diagonal. Okay, so let's do the same here. So first let's multiply the elements along the leading diagonal, the diagonal highlighted in red. So 3 times 7, 21, minus. Then multiply the elements along the green diagonal, known as the lateral diagonal. So minus 5 times minus 2 is plus 10, with that minus here, 10. Okay? Doing the same procedure here. So first multiply the elements along this red diagonal. 2 times 7, 14, minus. Then multiply the elements along the green diagonal. So 3 times minus 2 is minus 6, but with this minus turns it to a plus 6. Okay, so 2 minuses give you a plus. Plus, okay. Remember, red diagonal first, so leading diagonal first. Multiply those elements. 2 times minus 5, minus 10, minus, and then multiply the elements along the lateral green diagonal. 3 times 3, 9. Okay, so when you simplify further, 21 minus 10 is 11, so 11i. 14 plus 6 is 20, so times minus j, so minus 20j. And minus 10 minus 9 minus 19k, so minus 19k. So that is a solution for V1 cross V2. Okay. So I think another example is in order. So let's try another one. So here's example number 2. So if V1, so V1 is given by, in example number 2, 5i minus 2j plus 3k, and V2, so if we have a vector V2, that is given by 2i plus j minus 3k. So let's calculate V1 cross V2. Okay, so let's work out this cross product. So remember the idea. In order to work out V1 cross V2, so that's the determinant of a 3 by 3 matrix. So as I said in the previous example, the first row writes down the vectors I, j and k. So I, j and k always for the first row. Okay, and for the second row, write down the coefficients of I, j and k in V1. So the coefficients being 5, minus 2 and 3. So 5, minus 2 and 3. And in the third row, coefficients of I, j and k in V2. So in V2, the coefficients being 2, 1 and minus 3. Okay, so don't forget to write down plus, minus and plus. So I'm going to expand using that first row again. Okay, and when you expand, it's plus I multiplied by, cross out the row and column, so the row and column containing that unit vector I, and we're going to have minus 2, 3, 1, minus 3, so those are the elements for the first determinant. Minus j, so minus j. So cross out the row and column, so the row and column containing j. We have 5, 3, 2, minus 3, so 5, 3, 2, minus 3. So these are the elements for that second determinant. Okay, and finally plus k multiplied by, cross out the row and column containing that vector k, and we have 5 minus 2, 2, 1. So 5 minus 2, 2, 1. Okay, so let's continue further. So v1 cross v2, that is equal to, okay? So remember, when you expand further, it's multiply the elements along the leading diagonal, then subtract, then multiply the elements along the lateral diagonal, okay? So let me use the same colours. So remember, multiply the elements along the red diagonal, then subtract, then multiply the elements along the green diagonal, okay? So for all three of these determinants, it's red minus green, okay? So let's do that. So minus 2 times minus 3 is plus 6, okay? So it's I into 6, minus in the middle, and 3 times 1 is 3. Okay? Going backwards, it's a minus j. So minus j, open a bracket, multiplying the elements along the red diagonal. 5 times minus 3 is minus 15. Minus. Then multiply the elements along the green diagonal. So 3 times 2, 6. Plus k into multiplying the elements along the red diagonal. 5 into 1 is 5. Minus in the middle. Then multiply the elements along the opposing diagonal. Minus 2 into 2, minus 4. Together with this minus over here. Okay, so I hope you can see that. Together with this minus over here will be plus 4. Okay, so when we simplify, 6 minus 3 is 3, so 3i. Minus 15, minus 6, so that's minus 21. Together with this minus j is plus 21j. Okay, and finally 5 plus 4, so 5 plus 4 is 9, so plus 9k. So that is the solution for v1 cross v2. Okay, so that completes that example, and these are the steps in order to work out the vector or the cross product. Okay, so I hope you found this video helpful. Do related practice questions, and I hope to see you in the next video. Thank you.